Hi, I'm Rick. I'm Minga. I run Crack Me If You Can, password cracking contest. And I'm boy number one at World Object. Thanks for coming. That's a machine of mine running dual 6990 submerged in mineral oil. Cracks full blast and runs at 60 degrees Celsius at all times. I can't see what I'm doing on the screen. This is an actual video of the machine being dropped into the tank. It's a minute long, bear with me. It's the scariest damn thing I've ever done, knowing that I have a machine and it's about to be submerged in liquid.
It's pretty close to dusting, actually.
Yeah. Anyways, that's then it runs. Scary, scary, scary. Okay, I can't see what I'm doing, so. In Keynote, how do you go full screen? You remember?
Hit the play button.
That's screwed up, this.
Drop your screen resolution so you can see everything.
Yeah, who's not a Mac queen, so. I'll sit like that, it's fine. Okay, I'm really sweaty because I just forgot my laptop and had to run back to the homes and then run back here. Okay, so we're talking about cracking corporate passwords. So I'm a penetration tester. I got into password cracking because I'm a penetration tester, and so therefore I needed to crack passwords, but I always needed to do it better because I've been doing it since '99, and the default was, oh, I'm going to run John and its default rule sets and use its CHR files. It's it's basic brute forcing, and I'm like, oh, look, I'm cracking passwords. But then it got to be like, hey, I'm seeing patterns. How do I do it? Okay, so I want to start writing John rules. Well, how the heck do you do that? And remember, this is 10 years ago. So that's sort of how I got into it. I created Crack Me If You Can, stop by our table at the DEF CON area, and I've got an entire suitcase full of free shirts for everybody. I'll hand them out later. If you don't get one, I've got about 200 more coming to DEF CON. Okay, so what we're talking about here is password policies, because I want you to be cynical about them, okay? So the purpose, obviously, is to make people's passwords in enterprise be stronger. Okay, so that's the theory, and everyone does it and everyone trusts it. So that's the whole idea. Now we've proved over the last years, everyone in this room, that passwords on the internet suck. Thank you, Pastebin. Thank you, all the anonymous ding dongs that leak all this stuff. Hey, we've proved that. We've proved that people from random internet sites choose random passwords and they suck. Now we're all learning from them. I mean, we're all getting new words, new root words, we're finding new patterns and the thing. But the thing to remember is almost all of these sites don't do password complexity. Now some of them are slowly improving. When you go to the enterprise world, 100% of places are doing password policy. So the best example, the best data that you have, if you're not a penetration tester, is the LinkedIn list. Now, we've gotten to 90% cracked on the LinkedIn list, and that's fine. But were the passwords chosen for LinkedIn more complex than they were on, say, Last.fm or Rocky? Well, yes, they were. Were they harder to crack? Well, not kind of, but not really. I mean, we're still at 90%, or whatever percentage that people are at now, 92, I think is roughly what it is. So my point about LinkedIn is the people who use LinkedIn, it's not 13-year-olds and 14-year-olds, and it's not on some forum. It's enterprise people. It's business people. It's people like me. I mean, I have an account. My password was leaked. And then I put out a Twitter, there goes my password, go crack it. It's 20 characters, it's random public. It's already out there. I already changed it. And it's unique to that one site. So people like me have accounts there, okay? So the complexity requirements that people are used to in the enterprise world or the business world or whatever you want to call it, they went and used it on LinkedIn. So you can use LinkedIn, you can learn things from it. The point of this talk is all those password complexity, rules and things that people have to follow that introduces risk. It makes things easier to crack if you use it. So what kind of stuff? Okay, so what I have access to is, since I'm a penetration tester, I do all the basement stuff because it's fun and it's fun to laugh at everybody, but I have access to huge enterprise directories, Fortune 50, Fortune 100, when we're talking 200,000 users, 300,000 users, even more. People who 100% of them have to meet password complexity. So that's sort of a different data set than you usually see, on the internet. So usually, it's like length 8, you gotta have 3 out of 4 categories, so upper lower special digit, you have to have 3 of the 4. Okay, pretty standard stuff. So the .gov world or DoD or whatever you want to call it, more and more places are 12, 2222. So you have to be length 12, have to have 2 upper, have to have 2 special, have to have 2 digit, have to have 2, whichever one I didn't say, upper. Anyways, you get the point. Okay, so these are the rules that they have to follow. They're still humans. Humans are still stupid, as are users. So let's take advantage of that. But how? And that's what I kind of want to show you. So in a lot of places I'm starting to see, like if they have enterprise admins or domain admins, they have stronger policies than other places. Okay, let's take advantage of that. So the other big thing is, that I have access to in my work and that other people do is password histories. You compromise a domain, you have the last 6 passwords. You have the last 15 passwords. That is extremely useful as a penetration tester, but even more useful as a password researcher because they're forced to change their password every 3 months. They're humans. They can't remember. Every 3 months, they're not going to remember a random 12-character string. They are going to change a little thing in their password, and they don't think anyone's going to see their secrets. But meanwhile, I come along and I've got 12 history for 6 history or 3 history for them, and I can use that. If I crack an old one, I can change my tactic and crack the new one without having to go and just shoot at it blindly. Okay. The other big good thing is that a lot of times these are NTLMs, which is the fastest hash format to crack. Thank you, Microsoft. So that makes everything a lot easier. Now, at other times, a lot of times it's giant LDAP or SSO, single sign-on, and those are salted SHAs and this stuff. But if the same passwords live in Active Directory, so then you can go and crack them in a single sign-on world. Okay, so and like I said, most of them are dumb, 200,000 users. So what do I see? So here's what I'm going to do. I'm going to tell you about the stuff you already know, and then I'm going to show you stuff, and then I'm going to tell you stuff you already know as well, but with a twist. So what do I see? Okay, so database. We all know people use database passwords. Summer 13, okay? I just ran from the poems. It's definitely summer. Okay, well, yeah, we know people use that. Well, take Rock U, take Last FM. How many people used it there? What was the percentage? Now, go to an enterprise where you force them to change their password every 3 months. What's the percentage that Summer 13 is going to work? I mean, it could be 10% of the users have that as a password. You're forcing them to change their password every 3 months. In most places, every 3 months, the seasons change. Not repair roads, it's just winter. But, but other places, they have seasons. And so therefore, that's an easy thing for them to remember. Okay, and it's going to kill. So 90-day rotations introduces seasons. Okay, what do you think happens if you force rotation every month? What month is it? I know a really great 12-character password. It's September 13th, Oh, you maybe have a special character, exclamation point on the end. Okay. Now, we don't even know this. This is not rocket science stuff. But what I'm saying is in the enterprise, in the business world, this just kills. Kills. So it's right there, kills. So does this sort of policy, does this sort of attack work on RockU or the Last FM leaks, the big leaks? Well, yeah, it cracks some passwords. But what's the percentage? It's going to be really low. So it might just seem like, I know that's active big low. You're not telling me anything new. I'm telling you in enterprise, it's destroys. Okay. So rotational policies introduce this vulnerability. It introduces a challenge to the user. Users do not like that. They're going to invent ways to bypass this. Okay. What are these keyboard patterns? Big whoop. We know about keyboard patterns. Well, so I've been to places where they have new user training and they tell people, look, dude, seriously, you can't use the name of the company in your password. You need to have it needs to be random. And so some places will tell people about keyboard patterns. Okay? A lot of times, if you make a Windows admin pick a 12-character password, they got to type in 1,000 times a day. They're not using LastPass or whatever. They're going to make some keyboard pattern. So it's really easy these days with modern tools to combine 2 word lists. And then that's probably the best way to crack passwords for that match keyboard patterns. Using the built-in one and John at the external rule just blows. Okay, so so obviously you have a left list, you have a right list, bam, you're cracking 12-character .gov compliant passwords. It's no big deal. What we started to see is people realize that, and so they're starting to do things like doing a password and then adding something at the end. So don't forget that. Use your combination rules, combine your left and your right keyboard patterns, and then run rules against it. Okay, and it can be the standard simple rules, add a year at the end, add a number at the end, things like that. But I've started to see other things where you have the left and the right, and then bam, to put the things in the middle. special character in the middle because they're like, aha, this makes it so you can't figure out my finger pattern. So now the main thing in red there is finger patterns aren't just 3-letter. They're not 4-letter. Okay, they can be 2 4-letter combinations. You know, they can be 2 5-letter. They can be 3 4. So it can be QWER, ASDF, ZXCZ. That's a 3 times 4. Okay, so there's all these different combinations. So the person who gave the talk about detecting keyboard patterns, you have to think about every one of these. Dead one's in the room somewhere, and he has a pull script on his website that actually is aware of all these different combinations, and you can go in and say, okay, I want to do a 4x3. So you figure out a user is doing 4 3-character patterns. So in Combinator mode, it's really easy to do it, or you can pipe the standard in. John, question?
How common is it to see users doing like a 4-character pattern and then a 3-character pattern or something, or do you normally see them using the same cycle length?
Right, the question is, how often do you see like 4 then 3 as opposed to them doing 4x4? It's not as common, but like where I do see it is like if they're storing the password on DES is chopped at 8, a lot of times they'll do a 3-3 and then they have 2 characters. It's less common, and that's why like this works, but then you have to apply your rules to the output of all those different combinations. So what I do is I take Dead One's Perl script and actually make the dictionaries, and the dictionaries are static, and then you just use those static dictionaries that are just freaking huge. Use those in combination with rules. Okay, so here's a bunch of real passwords from active domain controllers from Fortune 50, Fortune 100 companies. Okay, so it's pretty standard stuff. You start looking at the ones I highlighted. I mean, everyone in this room can look at it. But like the top one is a 4x5. So it's a 20-character password. That's a pretty darn good password. Go ahead and try to root 20-character salted shaw brute force. But it's a 4x5. Standard stuff. You start to see some other ones, the dollar, QWER in caps, and a lot of these, you can look at that and say DoD compliant. Actually, I don't know what that term is, but you can look at that and easily see what's compliant for the larger ones. So those are all real. And it wasn't for a company named QWER. Okay, so while on the subject now, keep in mind, I'm still in the telling you stuff you already know category. Okay, so keep in mind double lists. This is getting more and more common for long passwords if you're active your domain. If your enterprise admins have to have 12 characters, they are going to invent methods. So combining of 2 words, and this is something we did in the last Crack Me If You Can. We put a lot of combining of 2 words. Okay, you require 2 uppercases. Well, I'm going to capitalize each word. You require specials. Where if someone's doing a combination of 2 words or 2 things, where are they going to put the special character? Well, usually they put it at the end. Sometimes they put it at the beginning, but in this case, a lot of times it's in the middle. The same things, the same stupid rules of leading a word. Well, it's still a combination of 2 words, but each of the word is leaded. So those are all relatively real. I kind of changed a few of them to Professor Redmond's not real. But it kind of gives you an idea of the other techniques in advanced situations that people are using. You'll see these on the last FM stuff, but once you start requiring 12 characters, you're really going to start seeing these. Okay, so where's the number? Okay, we're jumping. I'm really fast. We're just jumping. So where's the number? So if you require a digit, where's that digit going to be 90% of the time? It's going to be at the end. Okay, so every one of your, everything you see, if you look at the default rules of any tool, and it's always going to be add a number at the end. So, well, some of them are going to be at the beginning, and that's fine. So if you require a special character, where are they going to put it? They're going to put it at the end. This is standard stuff, okay? And all the tools relatively do this. But as soon as you keep that in mind, and then as soon as you ask yourself, well, what if you require, okay, I require a number, I require a special, but I also require an upper. Well, then what are they going to do? Where are they going to put their upper? They're going to capitalize the first word, the first letter. Well, you look at John's default rules, it's got things like, add 2012, add 2013, but there's no C with that rule. So, it could be password 13, but it's going to try password in lowercase. So either your word lists have to have that, or you have to go in and change the rules and put a C in there, or you use hashtag and you combine the rules. So you use your standard rule set, whatever it is, and you just say, also use the cat rule, okay? So there is an order to where they put them and which special characters and which numbers. So what's the most popular special character in a password? Exclamation point. Okay, what's the least popular one that I see? The British pound sign. Because only people with that on their keyboard can use it. But if it's international companies, they're going to have things like that. So there's an order to where they're placed and which characters they use. Now, we come along, we run John or something like that, or we run a brute force. Do the tools know this? I mean, if you're using John, he uses the static CHR files that come with it. Is it using this? Does it do it the best way? I don't have an answer for that. Okay, so just keep that in mind. That if you go and like, if I'm brute forcing like blowfish, okay, or $6, those are gonna be hard as heck. I'm not gonna do a question A, question A, question A, and then question S for special. Because it's like, no, that's going to take bloody forever. I'm going to go and say, just do the exclamation point at the end. So we talked a little bit about rotation. So as soon as you enforce rotation, you're introducing vulnerability, okay? So users will use the same root word, which is just like a term I made up. They're going to have the same root word, and they're going to change their specials, they're going to change their digits, maybe they'll change their capitalization or something like that, okay? As soon as you learn the root word of a user, you can then go and target it. And that really helps in penetration tests when you're doing like Microsoft Cache credentials. You get one from a year ago, I figure out their root word, oh wait, it's a river in India. I'm going to go and just make that river in India be my word, try all my rules against it. So the users will use the same patterns, the same topologies every time. I mean, it's just standard. And that's what you get from password histories that you don't get from just getting a static list from a single site that's been owned. So things like Smith Wesson 12, Smith Wesson 13, Smith Wesson 14. So what's going to be the next password? Okay. So users wouldn't do this if you didn't force them to do it. Okay, because they don't think anyone knows their secret trick. But their secret trick's pretty stupid. So anyway, so all of this is old news. That's nothing. This is all default stuff. We all kind of know about it. We can all tune our tools to do all this. Back in 2010, I released a whole bunch of rules that were based on these kind of ideas. All my rules were all like, the very first thing was cap everything, because 80% of the time in enterprise, it's going to be that first letter's capitalized. Take every rule you have, add C to it at the very beginning, and go from there, because that's going to kill an enterprise. As soon as someone comes along and capitalizes the second letter, a password, makes it a capital A instead of a capital P, it's like God's harder, just because they're not doing something that's trivial to us. Obviously, it is trivial to us. We can do a T1 and whatever. So some other cool things that are going on. This guy Marcus, he runs the site for Red Agent. You can go there and he wants your money, but you specify a company name, they do a bunch of Google, and then pull out a bunch of words from like Wikipedia and from the company's websites of where that company is located, what that company does, and like words from their website. Because if I'm going to go do a pen test, or I'm going to go target a company, and the company I'm going to target is, let's say, Target. Okay, well, what does Target sell? What do they make? Where are their offices? Oh, their corporate office is in Poughkeepsie. Okay, well, let's put, you need to use Poughkeepsie in your word list, okay? Because that kills an enterprise. Kills. If your client is in a location, you use that location. You use that location's sports teams, things like that. It absolutely destroys. It's like using the word last or last FM to crack the last FM list, or using the word rock or rock you and rock you list. Same exact idea. It's not rocket science stuff, okay? Create your own Markov chains. If you're a John user and you're just using a.chr, you're missing tons of stuff that's based on Solar's word lists from gobs. Who knows? I mean, I asked him, like, hey, why don't we update this? And he's like, it is based on my research. It is, oh crap, we're streaming, aren't we? He lives far away, so. So anyway, so make your own based upon your data set, because, and even if your data set's small, or make your own Markov chains, whether it's in John or in hash category like that are based on what you're seeing. Because as soon as you bring in your all.chr from John and you're going after 12 passwords, it's just not going to work. You're just wasting your time. That's illogical. It's all about using logic. Okay, so users are human. The types of users will what am I trying to say? It will affect what their password selection is, okay? Companies have a finite amount of types of users, okay? You get Unix weenies, they got Mac nerds, they got Windows idiots, they got janitors, they got executives, they got marketing, they got salespeople, okay? It's pretty standard across the board, okay? And then you have various levels of the types of users. If a company outsources to India or has a large percentage of Indian employees, which is common in some places, or pick other country, guess what you should use for word lists? The best example I have is on this pen test. It's actually a really challenging one. I had a blast with it. I eventually, via Mimikatz, got an enterprise admin's password. I dumped it out of memory. And it was 2 words, just both of them capitalized, punched together with a number in the middle, and both of them were 2 locations in India. So I actually would have cracked it because I have a large India word list just from Wikipedia, but it's just 2 crazy long words that meant nothing to me. I had to Google them, and one of them was like a river, and the other one was, like some small village. It means nothing to us. It's a really easy long word for them to remember. So obviously having lists of names, the Facebook name list that was put out 2 years ago by someone in this room, but match them to your target. Okay, so pretty standard stuff. White Pro, Centel, has anyone ever heard of these companies? You go to a place and they'll have 500 or 200 White Pro consultants. The funny thing about all of them? Every one of them has White Pro in their password. So you can go to a place and it's real easy to find out if their 8-character password is White Pro 123 or White Pro 13 exclamation point. The same with whoever Centel is. It's almost like all their employees do that. Now, do you see that in Last.fm or RockU or LinkedIn? No, you don't, but I'm telling you, it'll crack a significant percentage. Okay, so patterns. So what's new? Patterns. Everyone's been talking about patterns. We know about patterns. If you're John Reeves, left cookies, but like in Hashcat or whatever, so obviously patterns aren't new, okay? You can use them as standard in. So, but I want to show you how critical they are for enterprise, okay? Because keep in mind, we're talking about cracking NTLM, that's fine, it's super fast. But what if you're cracking salted SHAs from an LDAP database? The big long salted SHA with SSHA in the brackets. You can't just brute force. You got 5 days, you have to use strategery. So obviously, like the best example is upper, lower digit, and that's it in Hashcat format there. So, on a system with 4 7970s, costs about $1,600, $2,000, takes 5 seconds, okay? So as opposed to doing an 8-character brute force, you can start with that one pattern in 5 seconds, crack things. So obviously, these are just basic examples. We all know this, upper, lower digit, cracks things like Austin 13, exclamation point. Okay, big whoop, this is not a tutorial. But the thing is, these patterns are universal, in quotes, between different enterprise networks. Just like they're somewhat universal, the Last.fm list or the RockU list, or other big lists that you have. They're somewhat universal. 6-character low, that'll crack a 13-year-old password pretty easy. In an enterprise, every enterprise has to meet, all their users have to meet password complexity. If you figure out the patterns used in those kind of environments, they're going to be different than what you're used to seeing. They will destroy. So, I haven't seen until just the other day password complexity checks that are aware of this and then prevent people from choosing passwords regardless of what the word is, based solely on placement of where you put things. So if it's an obvious word, special character, that's the kind of thing that we need to prevent. And so we're working on it. It looks like someone else is already working on it, things like that. So the type of root words, because we're all about word lists, oh, I got this insane word list, I got a great word list, is actually starting to be a little less relevant. Now I still use them still. I still disagree with my own statement, but it's no longer the most important toolbox. If you know to do upper, lower digit for making 8 characters, and that cracks 15% of 200,000 users, that's better than any word list. Because what if their pattern is still just a random gobbledygook word, but it meets that pattern? And that pattern works in 4 seconds. So, no public, in quotes obviously, no public leak is from large corporate networks. Think about the big leaks. Now every once in a while you'll see like a few hundred NTLMs pop up on Pastebin, and they're from a single place, and I get all excited. Woo, oh, look, man, okay. But otherwise, you think of every big leak you've seen, none of them are from these environments, okay? And very few of them are from sites that enforce complexity that would introduce this vulnerability, okay? So all this research and everything like that, like building your word list as we're doing all this research and finding all these links, that's super beneficial for finding root words, but it's not super beneficial for finding the patterns. So, okay, so some other ones, so obviously, you know, an 8-character NTLA, you know, it can crack in hours or days, you know, you can do it in 6 hours, I can do it in 4 days. With a single machine, it takes, you know, so long like that. But, okay, well, what about 9 characters? What if they require 9 characters? Well, that's going to take weeks. Now, as researchers, we have weeks, but as a penetration tester, I got 5 days, okay? So I can't brute force that. And what if they're salted shot? You know, I mean, brute force that. So immediately, as soon as we start thinking about 9-character passwords with complexity requirements, these patterns become real important, and I'll show you how that is. So, like, you know, to give an example, you can crack half of the 9-character passwords just by using simple patterns. Okay. Now you crack a bunch with your word lists and your rules and things like that, but doing that in a few days versus trying to brute force is so much faster. So these are the most popular enterprise 9-character passwords, and this is just so obvious to everyone in the room. Upper, lower digit. Okay, it has 3 to 4. It's 3 to 4 patterns. It's more than 8 digits. Pretty standard stuff. So this is all, you know, kind of what we're used to saying. Not rocket science stuff. And that's kind of my point. This isn't rocket science. This is all pretty simple stuff. So let me show you some real data. I mean, since I am a penetration tester, since I do this, let me show you what we actually do see. So a very, very large company, very large, makes a lot of money and a lot of products that everyone consumes in this room. So 100% of their passwords meet complexity requirements. Okay, so none of them are password lowercase. Okay, so in this case, we cracked, you know, almost all of them, thanks Landman, you know. So it was a really good research. So it's 263,000 users, not hashes. So we found 7,300 patterns. Okay, so you start thinking about the most popular patterns. There's the 8-character pattern. It's just a word, uppercase at the very beginning, 2 digits at the end. It's 12%. 12% of their hashes meet that one pattern. How long does that one pattern take to crack? About 5 seconds. Okay? So then, the second most popular one is 9 characters. So the second most popular, I'm just going to repeat myself, but anyways, it's 12% as well. Okay? And then going on down, you can see the numbers go like that. So out of the 263,000, we identified 7,000 topologies, patterns. Okay, that's all that means. So 3,000 of them, roughly, were used more than once. Okay, so the other ones were one-offs. Good for them. So the most popular one was used 33,000. It's 12% of the hashes. Okay, so obviously that's important. The top 5, so just the first 5 patterns you identified, it got 127,000 cracks, and it's 48%. So you think about NTLM, you know, it wouldn't take you that long to get 50%. Okay, it just wouldn't. But you know, that's if you're NTLM. What if you're salted shot? What if you're DES? What if you're $1? What if you're $2 What if you're $6 or $6? You know, what if you're in these harder ones? You have to be more specific in your ideas. So you take the top 100 patterns, you put those in a list, you run those. It cracks 225,000 out of 263. So just with 100 commands. In this particular instance, we cracked 85% of the passwords, using no rules, no word lists, just patterns. Now, I'm not saying that words and rules are worthless, because they're not. They're super, super important. But, so, how long does it take to run 100 patterns? Well, you know, it depends on the hash format, but not very long. I mean, you know, and the thing is with this, remember I said, these patterns are somewhat universal. You go to one Fortune 50, you go to the other, you're going to see roughly the same kind of patterns, because there's no enterprise tool that prevents patterns. There's enterprise tools that enforce complexity, but don't, you know, say, hey, that's an obvious word digit special, you know. So, you know, 85, getting 80% used to kind of be like the magic number. That's when I started to feel like, okay, I feel pretty good about myself. It used to take weeks. I mean, 10 years ago, you know, I had John on maybe a tool called Hulu, you know, but now this is so fast to do. Just by doing 100 patterns, and I don't even have to think about it. Like I can Like, hey mom, go run these 100 commands and you'll crack 85% of the passwords of the Fortune 50, you know. Okay, well, let's talk about a second example. So this is another example. This is a large single sign-on. Not NTLM, salted shots. Slow as dirt to crack. Could be worse, could be better. Now, they had password history, 6 per each one. Well, that is just pure data. That's great for me. Okay, so it is 449,000 real people, so big company. And we got, you know, almost 420,000 of them cracked in a certain amount of time. And we found, you know, this many patterns. Notice it's more patterns than the previous example. So the most popular patterns are there. They're all pretty obvious. They almost all start with a word, have digits on the end, or digit special, or 4 digits. Or, you know, they have a word special, then 4 digits. So then the least popular pattern is this god-awful thing. So the first 5 patterns at this place that I don't even have to think about, and I can just run them, crack 16%, you know? So, out of the 449,000, we got 14,000 topologies, okay? About 7,500 were used more than once, obviously they're useful. So, the single most popular pattern, it cracked 4.3%. Now that's less than the other example, so we're going somewhere. The top 5 patterns was used 72,000, which is 16%. So just by running 5 commands, I can easily crack 16.2, okay? Now remember, it's a salted shot, not NTLM, so I really need to use more strategery I have to be smarter in my attacks. So the top 100 patterns, so if I can run 100, you know, if I can say, mom, go run these 100 hashtag commands, you know, you can get 62% of the domain cracked. Now, notice the previous example was 85, so which place has better passwords? Well, based on patterns, it's this. This place has better, okay? Now, you know, better is in quotes. I mean, it's obviously, it's all, you know, it's up in the air or whatever. But anyways, that gives you an example of how important patterns can be, okay? Now, we all know about patterns, but you know, it's nothing new. It's nothing new, but it's like, you know, before John came, or before Hashcat really came around, it was like I was doing this stuff where I'd have a C program, spit out these patterns, and then type the John standard in. I mean, that's the way it used to be done 10 years ago. You know, you had to write custom code. Well, now, you know, you don't have to do that. You can do it on command line. You can automate all this. So let me tell you how we do it. Learning all of this, learning that, hey, the types of words that people are using from word lists, the types of rules we're seeing, we sort our rules based on the ones that crack the most results. So it's not just a giant list of rules, we've done the research, done the math, and we sort them based upon how good they work. So, you know, you start looking at them from the top down, but they're based on previous results. Because enterprise to enterprise to enterprise to enterprise, Fortune 50 to Fortune 50 to Fortune 100, it's the same kind of people. There's Unix wings, there's Max nerds, there's janitors, there's Unix users, you know. So anyways, okay, so warning, sales pitch. So our tactic is, I want to crack these. I want to crack them on a large scale. I want to crack them on a lot of machines. But I don't want to have all the machines in a room and have them be on InfiniBand and have them do VCL. Okay? It's just not what I'm going to do. It's not, I don't have that situation. What I do have is GPUs all over the country in people's houses and various colos and things like that. So what we do is you share the hash list between all the machines. Okay, so every machine gets the hash list. Now you got to make sure you do it securely. All our hard drives are encrypted, blah, blah, blah. Okay, and then when you're done, you delete it so that you're not putting these hashes at risk. You share the word lists, you know. So you have a central place where all your word lists are. You share them between all the machines. The same with your rules. If you make a custom rule, you put it on one machine, it's distributed to all the other machines. It's therefore used the next time they do that. That's a dynamic process. It changes. It's in flux. If you figure out a new type of word or a new type of rule that totally destroys, you put it in a centralized place. It's sent to all the other machines in the grid. So you create a queue of jobs to run. So what jobs am I going to run? So backing up for a second, what's the goal here? The goal here is for me to press a button and to crack 85% of an Active Directory domain without thinking. And that frees my brain up. I don't have to think. I can go and do this and crack a large percentage, and then I can concentrate on my job, whether that job is penetration testing or my job is knowing, hey, let's not even try for those easy ones, let's try for the hard ones. So I've got my own GPU that's not in the grid, and I can go and use my brain. Now at the same time, we've got 300, 400 CPU cores doing the same thing. And they're all doing their things logically as well. So I can hit a button, everything can go, it can go and automate it, it's done by logic, it's not brute force. No, I can do it brute force, but it's done by logic. Now half the people in this room are going, bullshit, you can't automate what I do. You know, that doesn't make any sense. You know, you can't, no, this is a science, this is an art. You know, the thing is, I've got 300 cores. You know, CPU cores, and I've got, you know, I only have like 10 or 12 GPU cores now, but that's going to grow. If I go and I buy another 4 GPU machine and put it in, I don't have to go and manage it, it's going to manage itself, okay? So you create a queue of jobs to run, and that the queue is based on what we've seen in different enterprises. So the very first job I run, what is it going to be? Well, it's going to be the most popular, from other companies, the most popular command to run, whether that's a word list in the rule set, or whether that's one of these keyword patterns, or one of it, or maybe it's a topology pattern, things like that. So you make a list of these, you know, and as it goes down through the list, they get a little more common, like the word list is like rivers in India, and the rules you're using are some obscure rule that you've seen once or twice randomly, things like that. You put them there, a GPU says, hey, I'm not cracking, give me a job, it sends its job, it runs it, it uploads its results, it says, hey, I'm free, give me another one, okay? That's being done on, you know, 10 machines, 20 machines, 400 machines, all across the internet. You know, I mean, you know, insert long discussion here about the protocols and how we use private keys to make sure that anyone can't do that. So essentially, I can scale this infinitely. And just any machine, you know, anyone in this room want to be a client, here, run this, and then you're a part of a grid, and you're not just helping a brute force. You're not running part of a VCL job. You know, you're not even using all the traffic, you know, bandwidth. So, as you go, the hash list shrinks. Now, that's not super important for NTLM, but you start thinking about these salted SHAs, and you're starting with 300,000 hashes. Well, after a while, you're 80% cracked. All right, well, what's 20% of 300,000? Okay, well, 10%. So now you're down to 60,000. Well, that's a lot less salts. So you're being smart, you're being faster. You're going to crack smarter. You shrink it as you go, the new machines, blah, 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 centralized monitor, blah, blah, blah. Now, there's no VCL, there's no location requirements, there's no special hardware. We have a new employee, we ship them out. Here's a free PC, by the way, it's got a $79.90 in it, we'll give you $50 a month for power. And by the way, it's going to be screaming hot 24/7, and you're not going to know why. Well, you're going to know why. You know, or we set it up to say, okay, well, at 6 p.m., theoretically, the person's done working, that's when it starts up and does jobs. So it cracks from 6 p.m. to 7 a.m., and, you know, we've got flexible things. Now, theoretically, you could go and fire up an Amazon EC2 GPU cluster and run the jobs there. Now, we'd never do that. Why the heck would you send your hashes to a third party? That doesn't take security seriously. So, you know, you talk about Moxie running the thing for $20 and he uses a word list. Great. And he says right there, I run this on an Amazon EC2 cluster. Well, good thing those things are super secure. Okay, so how do we improve? Okay? So anyway, the reason that's a sales pitch is because, you know, we're going to start selling this to our clients as a service. Okay? And that's our general idea. But I wanted to sort of talk, you know, I'm not going to sell to you all. You have the money, look at you. But it kind of gives you an idea of how you can distribute work and do it in a logical manner. So how do we improve? Well, create policies, password policies in enterprise environments that are aware of this, that are aware that these 5 patterns can lead to 60% crackage. Is that a word? Okay, now if someone showed off something that's starting to do that, and that's great. Now get it rolled into an enterprise. Now get it rolled into SiteMinder. Please, SiteMinder, SiteMinder. If you don't know SiteMinder, it's used everywhere. It's real expensive. You know, have it rolled into single sign-on, have it rolled into PAM modules on Unix, have it rolled into Active Directory, have it be a module, things like that, because I've proven that regardless of words, regardless of rules, you can take 5 command lines and in some cases crack this huge amount. So those things, it's really unpopular. So yeah, so we're working on a solution, and you know, but you know, someone else has already got a working solution. So my thing is I give this talk to techies and to managers and stuff like that, saying, dude, your password complexity, it doesn't work. It introduces things. Okay, so that's the basic idea for my talk. Some other little things, just because I think I have a few minutes. I run GPUs submerged in oil. It's a crazy idea. I did it, and I'm going to keep doing it. So I'm going to buy 20 Euro rack space and fill it with 4 7970s. They're all going to be submerged in oil. You have to do a few little things like use solid state drive. You have to remove the fans and the heat sinks from the cards, scrape off that silica, that goo, whatever it's called, the stuff. And you have to replace it with a piece of like this special aluminum foil, and you put the heat sink back on. No fans. You use less power because you're using less fans. And a big 4U chassis full is 150 CFM fans. You're not using any of those. So theoretically, your power usage goes down. So therefore, your colo, wherever, charges you less. My machine that installs submerged oils, dual 6990s that were overheating in there. They were hitting 90 degrees Celsius immediately. And regardless of how many fans I put on them, now they run at 60 degrees Celsius 24 hours a day, and they're fully utilized at all times. I don't even think about them. I don't even know the machine's in oil. I have no idea. Will it last long term? We'll see. Change your last IFM password again. So crack me if you can. I got a few minutes. I'll talk briefly about crack me if you can. It's bigger this year. We have 7 people working on it. 5 will be at DEF CON. We have street teams. So the pro teams are competing for my hard-earned money, $1,000 in cash. But the street teams, you're not going to be competing against the pro guys. You'll have your own little category. Smaller teams, I don't care. You don't have to be at DEF CON, so your friends can play at home. And there's going to be like door prizes for the street team. So it's not like you versus the big guys. You can compete with the little guys. Well, we're going to do door prizes this year. Like every hour, we're going to publish a hash at our desk, and the first person to crack it, wins a T-shirt or wins a poem plug, or wins whatever our little prizes are. So there's kind of a benefit. So that way the people can kind of get involved, and because when we're sitting there, we'll have university students come up and be like, "Oh, dude, I've got a cluster of like 1,000 machines at home, or at my university, just sitting there." And so we wanted to kind of reward those kind of guys. 2 other things: an online petition to dissolve NTLM. I think we're the community to do that. I don't think they'll ever do that, but getting the word out that it blows is a good idea. The other thing is the big reason I started Crack Me If You Can was because it was started kind of as a dare. One of my founders of my company, Hank, maybe if people know him from Crack Me If You Can, was like, if we ever meet someone who can write John Riddle rules and can understand them, we have to hire them because that means they're smarter than us. Okay? And that was years ago. So 10 years ago, how many people could write John Riddle rules? How many people could write them and then have Solar not rewrite them and then berate you when he did it? Because still, I write him and he's still like in the comments, he's like, I don't know why they did this. I don't know why I can do that accent. I can't do a Russian accent. Yeah, it costs me. So, how many people were at that level? How many people were at that level 10 years ago? How many people were at that level 5 years ago? Now, we've got a room full of us. Look at us. We're all sitting together. We can all do it. We can all understand it. I can talk about doing a T1 rule, and half the people go, yeah, talk. I know. I really like the way the community is going. There wasn't a community before. There was mailing lists of people on how the hell we're doing this. So I think it's good because we're proving to people and proving to enterprises and proving to hack sites that are getting owned about the importance of using proper hashing mechanisms, which is just like boring. It's a snore fest for me, but people weren't getting burned on it before. Last IFM still uses raw MD5. They now they compromised it twice. They didn't change their hashing between the first and second compromise. If LinkedIn got owned again, would they still have SHA? No. So it's our community that's going to get this out. It's going to get the word out there to help enterprises improve what they're doing, help them fix the problems they don't even know about. Because enterprises, they don't do password audits. It's like when I go in there and I do a pen test, I'm the one that tells them what their Unix admins are doing. Because you can't go to a Unix admin and like pull their beard. You're like, tell me your password. You can't do that. If they don't have a beard, they're on Windows. So anyway, I totally like shavers when I love art. So my point is, thanks to everyone, because look at you, we're sitting in a room. We're the ones that are doing it. We have authors of the tools here and stuff like that. The techniques that we're doing, and everyone's sharing. That's the big thing with Crack Me If You Can, was we required at the very beginning, and I don't know what year was it, 2010, was we required the winning teams in order to get my hard-earned money, we required them to write up how they did it. And this is why, because I wanted to grow. I put in things this year, like the last example, last year we did Sun MD5, and the reason we did that is because I'm a dick. Because I knew that you could only crack Sun MD5s on a Solaris machine with the proper library. So everyone's like, how the heck do you crack these? I'm like, dude, it's published. I'm like, yeah, but no tool does it. And they're like, hey, I know. Now, there's multiple tools that crack Sun MD5. Well, guess what I'm doing this year? I'm doing more of that because I want the tools to improve. You know, and honestly, just tell me to shut up because I will talk for hours. An example, I'm at Technoforensics conference years ago. I'll just do a while and take my pants off.
No.
Pictures.
Yeah. Anyways, I'm at Technoforensics conference. It's a semi-technical conference with forensics guys. 80% of the people there are cops, are feds, and so many of them are forensics guys. I get these two guys come up from a county in Georgia, and they're like, hey, talk to us about DMG, okay? They're child porn investigators. And they're like, we busted this guy, his wife turned him in, he's going to jail, we have him on they found 3 images in his disk cache that were deleted, but they were pulled because they're forensics guys, so he's going to jail on 3 counts. The thing is, when you find something like that, that's 3 separate charges. On his laptop, they found a like 2 gig file, and it was called corruptedfiles.dmg, and it had a password on it. And they were like, help. Now this was like in 09, okay? And I had to be like, I can write you a bash script that'll do like in 1 second. And the thing is, they had all these old passwords and it didn't crack the DMG. And they knew that like, if that DMG, I'm pretty sure it wasn't corrupted files. I mean, this is a convicted pedophile, okay? So it got really quick, okay? So what eventually did I do in Crack If You Can? I put encrypted DMGs in there because I wanted the tools to be able to do that, specifically so that I could help these guys. So like, you know, we're not all bad guys. You know, I was talking to Ozzy, they're doing password cracking as a service as well. You do a lot of forensic stuff. When you're doing forensics jobs and people are doing incident response, those are bad guys. You know, and sometimes they're bad guys. So using everything we learned, it can be used for good. You know, it can be used. I would love to crack that DMG and get that child porn guy. And I know that's really got really quiet because it's really serious, but like, it's still a human choosing a password. And so in forensics cases, I mean, you know, a bad guy comes around, encrypts something, and look what I did. You know, you can use the same logic, the same everything for the power of good. So as much as we all love paste bin and getting those large leaks, and for God's sakes, please keep doing it. You know, the worst thing that, I told you I'm not going to shut up. The worst thing that's happened in the password cracking community this year, paste2.org, they changed their, when you make a hash, it used to be a sequential number. They changed it and made it random. So you can no longer run a script that just goes and does 10 at a time, and get all the pastes. They made it random. That's like the worst thing because all of a sudden you no longer find paste2 password leaks on there. And that's, you know, and everyone knows about last.fm. It was from Inside Pro, was where it was leaked. And now all of a sudden Inside Pro's forums, people are a little more scared to post there. So that was an unfortunate outcome of last.fm. Finger on the nose, okay, for everybody. So, any questions? Like I said, I will just talk. Yes,
so what, I mean, given that we've been trying all of this password complexity rules and everything else for the last 5-10 years, people know that passwords matter, and we can still beat on them like a pinata. Where do you see things going? I mean, are we just, do you think that we're going to be able to get off of passwords at some point, or new algorithms, or where do you see it going?
I'm glad I don't work in enterprise because they cannot change their tools, you know? And so every place I know is just like, boy, I wish I worked at RSA. So many places are going two-factor. So many admins are going two-factor. It's just like they see it as the only way of doing it. It just sucks, you know? We use two-factor at our company, and you know, there's no passwords. Go ahead and compromise the machine. There's no passwords. It's all, you know, it's all SSH keys and blah blah. My point is that you too know what's wrong. You have to audit. I hate using the A word, audit. It's like a bad word in my household. you have to audit. Enterprises don't know what their users are doing wrong. They're not particularly, unless I show up and do a hack or, a penetration test, or a real pen tester shows up and does a real pen test and performs that audit. They don't know. So like they're still in baby steps. They still think what they're doing is working, okay? So I still see growth before we even get into new technologies. I still see growth that needs to be done in the enterprise world to make our users smarter. I mean, how many websites that you go to have password complexity requirements? Okay, think a percentage in your cynical brain. How many of those websites 5 years ago had password complexity requirements? How long is that going to be acceptable? How long is it going to be acceptable that we allow our users to sign up for a PayPal account and choose a crappy password? That's got to improve. We're still in the baby step stage. I'm done. Question? Yeah.
In the major password cracking programs out there, what types of hashes are not supported right now that you think should be supported? I don't break there too, so I mean, it's not.
You'll find out tomorrow.
Yeah, you'll find out tomorrow. You'll find out tomorrow at 11:59 p.m. As a penetration tester, I see certain things that are just going to get obscure, and you're like, this is bullshit. He's just being me. There are programs that have certain ways. The progress in the last 2 years has been amazing. I mean, it's to the point where, like, I would bitch and moan to Adam because I couldn't, to crack the salted shaws from an LDAP database, I'd have to convert them. I'd have to base 64, which turns it into a binary salt. So like, they don't all fit on the single line, because some of the salts have binary high ASCII. And now it's built in support, and it just works. And it's 1,000 times faster when you're on. Zing! So like, I forget the question. I'm not going to tell you. I'm not going to. But the thing is, like, what's missing is shrinking so much that like 7 of us are sitting in a room going, okay, how can we fuck with these guys? And I've got one of the challenges this year. You're not going to be able to crack it, but it's just going to take. It's going to take a dev about 10 minutes to figure out where is this from, what is it. It says right in there what it is, and to implement it. And if they implement it, they're going to ask lower points, because the goal of Cracking If You Can is to improve the community, is to improve the tool set, is to improve the rules, is to improve the knowledge. Yeah, it's also to laugh at your failures, which is fun for me. And then the side point of the contest is to force everyone to learn BGP, which is the biggest complaint. We require everyone to use BGP, and no one uses it. So anyways, thanks a lot. I'm Rick. I'm Ninga. I'm Cracking If You Can. Oh, I have a